This is worksheet 25.5, and we're going to look at the problem for number 3 and 4. Ms. Norbury's calculus class has 27 students. She must choose 5 students to compete with the mathletes at the regional competition. How many different groups of 5 can Ms. Norbury select to compete? So on this lesson, the main thing to look out for is whether or not order matters in the question that's being asked. So in this case, she's choosing 5 students. There's no order involved. She's just picking a group of 5. So in that case, this is considered a combination. And the format to set a combination up is to take the total number of things or people, factorial, in the numerator, and then in the denominator, we need to divide by the number of students that were chosen, which is 5, as well as the number of students that were not chosen, which is 22. Then evaluating this expression, here in the numerator we have 27 factorial. So if we expand that out, rather than multiplying by everything all the way down to 1, I'm going to just stop with 22 and use 22 factorial instead of writing 22, 21, 20, and so on. Because in the denominator, the 22 factorial is going to end up canceling with the one on the top. So this is a lot less time consuming than writing 22, 21, 20 all the way down to 1. The 5 factorial I need to expand. And then at this point you could reduce, or you can just leave this and multiply the numerators. So if we multiply the numerators together, and then divide by the denominators, make sure you use parentheses if you're using your calculator, and then we get 80,730 different groups that could be created. Number 4, Ms. Norbury must determine the order that the competitors must answer the questions. If she already knows which 5 students are in the group, how many orders can she create? You can look at this a couple ways. If she already knows which 5 students are competing and she's putting them in an order, you could create a decision chart. There's 5 different students that could go first, then 4 students are left that could go second, and so on, 3 and then 2 and then 1. Here, 20 times 3 is 60 times 2 is 120 different orders. This is also something you could think of as a permutation. This is just 5 factorial. So if you were to use the permutation formula, as opposed to combinations, permutations are when order does matter, and in that case you take the total and divide by only the number of people that were not chosen. In this case, all 5 students are competing, so we could say 0 students are not chosen. 0 factorial is defined as equal to 1, so you end up with 5 factorial divided by 1, which is the exact same thing we did here with the decision chart. 5, 4, 3, 2, and 1.